Okay, good to be back live here. Here we are. Hi. I've had a long morning meeting followed by a run in this scorching hot sun, followed by other stuff. And I've got another meeting later. So I got a couple hours now. I figured I would do a quick research stream. Mainly, it's going to be to check and think about some of the experiments from yesterday. Hey, Jess. Welcome. I mean, this is kind of cool, right? This sweep that I did here. What is the max score that we've gotten? Okay, there's only one of these that is over 800. This one. Oh yeah, it's got this massive spike in it. 827. So it's this is not bad though. Like we're very close to solve just by doing a few very dumb things, right? Actually, let's do this. Breakout no skip. Okay, so with 40 mil frames, we actually have, and this is 40 mil with no skip, so it's actually 10 mil. We have a good number of stable solves. Looks like 35-ish. Okay. That's not bad. This is... Okay, this is slightly harder. Get rid of the filter and see if we can get the distribution. Okay, so without skips, we've got this actually pretty good range of solutions. This decay actually seems to not help, interestingly enough. That's weird. Possibly doing it wrong, but okay. And then we do... Yeah, this bigger architecture also doesn't seem to do much for us. I believe this is the jank one, right? This is jank. This is not bad. This seems like there could be something here. Hello, Kyoko. Welcome. And then this was my combined thing. Steps. Actually, having fewer M's definitely... This seems to help, right? Fewer M's run. We're not quite at the 5 mil solve yet. My brain is like... It's not even that I've got noise. Like, normally the thing that makes it difficult for me to do research is noise, right? It's like, I've just been, like, looking at too much different stuff, and it's all, like, jumbled together. Now I'm just tired. It's very clear, but I'm just tired. Welcome. But that's fine. This is actually, this is the type of stuff where we can make progress just with a little bit of slow, simple thinking. Do we have... We should have some nice dashboards, right? We get learning rate thing. Surprisingly, there's not actually a good trend in update epochs. Higher value coef, it's the same as before. Grad norm's gotten reduced a bit. A little higher entropy than before. Okay, we actually have a peak at 64 horizon. Nice to know. Oh, did I just fix this to not use that many M's? This was 64 M's. This was 128. We go to 128 M's for a bit. And this decay thing did not help. Well, maybe it's you're not supposed to decay lambda. Or maybe it's hard for it to discover what it should do. Or maybe it doesn't matter in this env. Okay, let's just take a very quick distraction. This. Is that good? I don't actually know if this is good. I think that this is... Yeah, these intersect, right? Okay, yeah, this is not super great. Oh, hang on. Alright, whatever. Something there, but nothing conclusive. Fine. Summit says, hello, I'm currently pursuing a bachelor and applying for internship. You want experience? Or master's? How can I get... Yeah, so that's tricky. Internships in AI and ML. You kind of need to have evidence that you've done something reasonable, right? Like some impressive project that you've done or some... I mean, for at least the ones that will talk to you, you just need some clear evidence that you can do useful work. I mean, this did something super weird, but I think we generally have like some reasonable enough stats on this, right? Any advice on encoding in multi-discrete action spaces? Uh, this is for chess, right? This chess is 8x8, right? Or am I stupid? Yes, it's 8x8. So, could it just be 64 and 64, which is like any start location on the board to any end location on the board, I suppose? I mean, technically it could also be, you could technically do like, there's like a pointer networks angle that could work better. It's just hard to make all these different action definitions sane and fast. I mean, I suppose it's promising here that... Let's take a look at this run. I mean, there are a couple different runs. They all have this sort of spike at the end. Oh, well, the spike is just from, like, after you clear the first screen. It's pretty easy to clear. Okay, that's fine. Okay, so let's see. Let's grab these params and see if this thing repros. Promotions as well. You have promotions as well. Do you ever just not take a queen? Castling is fine, right? Castling is... It's still a from and to. It just gets interpreted slightly differently. Is there anything else? I mean, except in like the super rare places that like there's like a super rare case you might take a knight, right? But other than that, don't you always just take a queen? Or am I off base? As much as I like games, I'm terrible at all games. So that includes chess. Except MMOs, maybe. Passant. Yeah, that's like Reddit's favorite thing, right? Next to instead of diagonal. Who decided the rules of that game? Who decided that you should have this perfectly simple game with a few random stupid rules that make it much more complicated? That don't even come up most games. Hello, Bet. I really should just make a thing to export all these params, shouldn't I? Why the fuck would I use an LLM for this? So that it can paste my parameters wrong and give me a completely bad impression of my experiments? Any frontier model. Yeah, MD, get some help, man, but I'm not having this in my chat. FBR. Cause pawns to sneak by. Oh, it patches that. Huh. Weird. I mean, these params are pretty... I guess not that nutty. Lambda's pretty nutty. Model's done post-mortem. Not entirely. But it's not going to be... World models are definitely not the general purpose, high sample efficiency, high compute efficiency bridge. Sea fish. That's cool. Kind of what we expected. Not necessarily. I would say that the literature turned out to be even worse than I expected by a significant margin. This is not bad though, right? We're almost to a solve here. This is 20 million frames without frame skip as well. I doubt this will work. I just wanted to try something real quick. 2-minute experiment still. Goes to show you, right? Genie 3 is a much easier... Well, at least along the axes that we're considering, bet it's much easier. Harder, obviously, on a bunch of different ones, but... It's not an interactive model, right? It's not trained. Not like you're trying to train an agent interactively on it. Phone off of Do Not Disturb. And it is how we do RL with transferable. You need to carefully define what the hell that even means. Okay, so this does not help at all. Probably the final evals are getting messed up as well, right? It's also weird that one update epoch. This thing has decided to only do one update epoch. Was it 64? 4096? So it's only 2 mini batches. Just a blanket. I can't think when it's hot, but then obviously I get cold. Also, it's good to be generally keeping my legs warm because they're incredibly frickin' sore all the time from all the running I do. Keeps my joints from locking up. The running has been quite brutal. It's the exercise routine is 6 miles on a very hilly course, 5 days a week, plus one longer run on the weekend, plus 5 days a week of lifting, including deadlifts every day. Quite a bit. Model you can say try to run a bike is now going to drive a car. Yeah, so the thing is, FBR, you don't get generalization from one task like a ton of other tasks. You get generalization from having trained on a wide diversity of different tasks. And then you get from that you can transfer. The thing that you're describing like probably doesn't even make any sense at a very fundamental level. And in fact is the thing that caused several researchers at OpenAI to waste multiple years of their time on a direction that didn't even make sense. I would tell him I told him so, but the team got the team was disbanded shortly after that. How do you classify a set of tasks and models? Yeah, well, humans are trained on a crapload of stuff and also have however many bajillions of years worth of evolutionary priors. Can you train a model that can train a model? Yes, you can. It's very expensive, though. And it's generally not worth it. Actually, if you want to have some fun, look up Gan You Do the Gan on Archive. I just, for the hell of it, when I was younger, I did an April Fool's paper in which I trained a GAN to output. I trained a GAN that outputs the weights of another GAN. It was something ridiculous like that. So I had a generative adversarial network that parameterized the distribution of generative adversarial networks. I thought it was quite amusing. Okay, so I mean this is rather odd at the very least that these are really the set of settings it's found. I kind of don't believe this is the most sample efficient thing, right? Like I don't believe this at all. Neurosymbolic AI. That's kind of what everything is. Like most systems are that to some extent. But then the thing is, it's like the people promoting that typically mean something completely different and are often complete grifters. So what do you think about your code in GanGan? It was just some simple thing I did, right? There's not enough code for me to have made a mess. It's generally fine code, but the project is too small for it to be like even a reasonable sample of anything. Like it took me very, very many years to go from that to what I'm doing now, right? I'm trying to think with this what I want to do. Isn't it weird? Pretty weird how this thing has set its parameters, right? Are we missing something? Or 'Yes, you can train a model on an unstable humanoid. What's the status of the new model? $827 with 20 million frames, no frame skip, which is like half the budget for the Atari 10 mil is actually Atari 40 mil. So it's going decently, but the parameters it's set to accomplish this are a bit odd. What kind of music are you listening to? None. I very, very rarely listen to music. Coffee. Just kind of baffled by this. You know, I do suppose, couldn't this be like an artifact? Robot? Not really. These days I go through a huge number, well, not while I'm programming, but I go through a huge number of audiobooks. Yeah, exactly, Jess. See, Jess, you figured it out. Half the reason I stream is because it keeps me engaged while I'm thinking about stuff as well. I don't just zone off, like, I don't just get distracted and zone out. Self-improving PufferLib when? You know, recursive self-improvement is something I would have expected to have happened by now. And it kind of sucks that it didn't. I don't really know why, either. I just don't understand how... Well, hang on. If it's a noisy eval, it could just be a combination of it being a noisy evaluation combined with us using time as the criterion, right? A few months. In a few months, this will be a research stream. It's already... What do you mean it is already a research stream? What do you think this is? Oh. Nah. That's more like for when I will ultimately get bored, solve RL, and start Puffer Labs or whatever for general science. I suppose it could end up being a facet of RL. It would almost have to be. It'd be kind of difficult to evaluate, I suppose, but honestly, it's not. Could just be done in an RL context, probably. I mean, there are a few things I can just try with this, right? 320. You'll get onto the puffer box. No, it's a fundamental algorithmic problem, Jess. Because it does seem like a fundamental algorithmic problem. Dota 2. That's MMOs for me. I've been playing like a little bit of League lately, and it's like I'm not remotely concerned that I'm just gonna like go play League for 5 years or something. Only like a real game heroin is MMOs for me. YouTube has like some auto moderation I don't think I can disable. I guess I just go. Let's just go change a few small things with the core optimization, I suppose. No, I'm definitely not a Zuckerberg type. And I will take that one as an insult. Well, I mean, I've never met the guy to be fair, but I think I'd take that as an insult. Definitely not soulless. I'm just pretty tired these days. At least until I finish this cut. I'm pretty upfront, like what you see is what you get kind of a thing, something. Like there's very little of what there's very little of me that's not just what you see here on the stream. And I suppose very little of it that's and almost nothing I would suppose that's even remotely relevant. I don't know if that makes sense. Well, yeah. Whatever. I really am not doing that much work at the moment, just like in terms of hours. Like the streams are pretty short. I don't even think I've been averaging 8 hours the last couple of weeks. So of course they're like meetings and other things. But it's a heck of a lot of my focus, right? Like I very intentionally don't have a huge number of outside distractions. And modify your house. You add this project to Puffer. This is on Puffer. And you oh, you're joking, okay. I mean I'm in Palo Alto, right? At the moment. If you're around the area, you'll probably see me at a breakfast or dinner or running or whatever around here. I mean, the schedule is pretty much like wake up, get some coffee, get myself into shape to go do my run and my lifts, get breakfast, get myself back and in order to start working on stuff as quickly as possible, modulo meetings, etc. Do stream, do dinner, and that's basically it. I mean, no, you can go handle that though, right? I'm staring at nothing here. Hang on. Yeah, it should just be. We'll do like this. This will increase the eval time. Okay, and then we bought. Yeah, the RL is gonna be go outside and go talk to people. It's gonna be go reinforcement learn yourself. Yep, so there are two things that I will not work on. One is short form content optimization, and the other is romantic companions, like romantic AI companions. Those are the two things I won't work on. I am way more happy to work on killer drones with RL because that is way less dangerous. Thank you very much. Alright, enough of that something. The research stream, for fuck's sake. I bet you if I just rerun this exact thing, I'll get a pretty different result. Right? Let's get rid of a little bit of noise. Oh, did I miss? I missed something. I missed this. Able to scale up to... Yes, they will. Like many weapons. My personal best case scenario for those, though, is they make conventional soldiers useless as weapons. So basically, once you've destroyed all the enemy drones, there's really not any point in fielding soldiers. So we just kind of destroy each other's drones and call it a day. That's my best case scenario, I would say. Ah, NumEms is 8. That's weird. Wonder if that does... Why did it max out? Oh, it didn't max it. That's kind of my point, FBR. If war were to be turned into a pure test of economic capacity, without us actually having to bother killing each other, that's a heck of a lot better now, isn't it? CPU only. What? What exactly is an epoch on the same data? Yeah, so it's not well defined, Jess. It's just like however much data that you've collected in one set of forward passes that you're going to train on, that's the data of an epoch. So it's the amount, it's you collect some data, you're going to do some training on it before you collect new data. However much data that is, that's the epoch. All right, are we good here? I think we're good. So, this one should be a little bit different, right? Yes. 8Ms. Oh no. That's something else. I'm basically trying to figure out why. So I've been able to make this thing much more efficient, right? But it's only gotten like 4 or 5 times slower. You would think you'd be able to spend at least a little bit more compute to make the thing more sample efficient. And I suspect it's just the way that we're doing our sweeps. So I made some changes to that. And at least for the next few days, my expectation is we'll just kind of be playing with a few things. You go find SPR. So stupid if that works. This is like such a wonky, annoying paper thing. And we have to keep in mind, right? When they're defining this really stupidly. Because this is play. Where do they do their batch size? $32. Okay. So, and here they have 256. So, the thing is, when they're saying a replay ratio of 1, what they mean is every time you take an environment step, on average, you're doing a mini batch of 32 update. So we would consider that like update epochs equals 32, which is batshit insane. So what they're saying is, hey, look, it's really hard for us to go from batshit insane to like batshit insaner. That's what they're saying with this. They're saying like, hey, you know our like stupidly slow and inefficient algorithm that's already completely impractical? What if we could double our performance by spending 100 times that amount of compute? That's literally what this means. This one's not quite as bad. This one is, hey, what if we could take our stupidly slow algorithm and double the performance by spending 16 times the amount of compute? But, like, these are both crazy. These are both completely insane. This is, like, Yeah, so this is a log plot, you see? It's log linear. So typically you get log linear improvements with compute, or in our case, we typically get... I mean, to be fair, I suppose if we get log linear returns on data, right, then practically you should take a midpoint, right? You should, like, probably not scale as absolutely insane as we have with data, and then scale some with compute. But, like, that point is actually below here on this graph already. Because the thing is, the starting point for this is already a batshit insane algorithm. In Puffer worth writing assembly for. Yeah, probably, like, specific low-level sims. Typically, you don't write big chunks of assembly anyways. You're just, like, inlining a few things the compiler's doing stupid. This plasticity thing is kind of annoying for on policy, right? I guess the hope is, like, at least for like reasonably sized problems, you kind of just assume that it's not a totally horrendous thing. You can probably, like, come up with some methods that don't require resetting the whole bloody network, right? If that's even a problem. I mean, here it is. But here they're doing, like, stupid numbers of updates. Okay, so this thing here is not crazy relevant. And this thing, I would like to understand if we can scale. Is there a self-supervised? Let me see what they did with this. I actually want to see the result from this. Hmm. Okay. Yeah, I wouldn't say, at least what I see, this is not like a crazy improvement. There is something to dynamics. But this is also, there's definitely something to self-prediction. Though I do wonder, like, this paper here, unless I read this wrong, they have this, right? They added this self-supervision thing. They're especially useful when we decrease the number of samples used in each update back to a minimum. Ah, okay. Removing. Okay, so the auxiliary loss is actually inconsistent. Not super clear evidence. How the hell does this thing only have 4 items? Ah, this thing's gotta be messing with me. Not bad. Initial. Was that initial run? Yeah. Initial run. Like this. Like a nice estimate, and we'll see from here. I think Neptune's just being weird. Like, data, like, rate limited us or some shit. But this is fine. This will run. think what else we need to look at. It bothers me. It bothers me that this is not scaling with update epochs at all. Is it guaranteed that you need to have update epochs? It's not guaranteed, right? It could be that the better optimizer just lets you use a way more aggressive learning rate and stay closer to on-pol. That'd be funny. I mean, it ultimately doesn't really matter all that much, right? As long as we're able to get a result. What other stuff is there? I mean, you can't trivially scale the architecture, right? We should probably make it so that you can change the network size. I mean, there's some small parameterization differences we could apply. I mean, I think I'm generally pretty comfortable, though, as to where all this needs to go. At some point, we will want to throw this on real breakout. But if I've done a good job, it should not be a huge difference. Frame skip 1 breakout. So then I suppose it's from there it is. What does this imply? I would like to have smoothly fit curves of some variety. Of course, torch compile and stuff probably makes a larger difference here as well. There's sort of a few different things, right? Grams. Yeah, I guess the only other thing I haven't really explored super well is architecture, right? Hmm. Explain why this is so slow. Is it just taking Neptune forever to, like, bullshit? Yeah, totally, right? Yeah, Neptune's just screwing with me. We might have to end up doing, like, a small local thing for this. Not today, though. Is there any evidence for alternative architecture? I suppose if you were going to do anything, the first thing you would do would just be like a basic fast slow LSTM, right? Oh, I also never tried multi-layer LSTM. How exactly does this thing work? Wasn't this about what I got? I thought that was what I got. From the same year, isn't it? Look at this. Same year. June? Literally the exact same result as mine. That's funny. 0.19. Oh, it's the same. This is so funny. This was at the same conference. So we published identical quality results on the exact same data set at the same time. Heh. You know, I never tried we could try highway nets. Second. Okay, sequentially connected RNN cells. Can you not just add a basic ass like skip connect? I had another thing on this actually. So I don't think this is a great implementation. But I also did this thing. I literally saw like language paper. And I claimed this this name way before that. Where is it? Of course it's you can't look it up. I have the poster in my bedroom actually still. I think we could try just that as a baseline. Cause like the fast slow you would as a basic baseline, right? You would just add like an extra skip connect, no? Oh yeah, they literally have the same baselines, right? That's so funny. I didn't realize this was a thing. Huh. Actually, my model's better than theirs, isn't it? Yeah, that's right. So come to think of it, I didn't realize I technically beat this paper. I wonder if there's anything from that. There's no way that there's something from my old paper actually useful, right? That'd be so funny. Let me go check my old code. That'd be so funny. I mean, this is a pretty dang simple cell to play with, right? I forget, does this have one state? It does, right? Out. Oh no, you have this list thing. Well, didn't I actually make a half-decent poster for this thing? Stuff we can do here. I'd have to go with the cell formulation instead of I'd have to go with the cell formulation if I want to do architecture work. I think what I should do for now, the thing that makes the most sense is to kind of just do some tuning, right? So I have like a really strong tuned baseline in multiple regimes, and then maybe we play around with some architecture stuff. I mean, because like technically, right, if there is architecture stuff that makes a difference, I should sort of be able to do something with this, no? Not saying that this would be the best thing. Hmm. I do remember this, like, actually freaking working, though. You know? Like, the only reason that I have any sort of trust in this, and, like, I don't necessarily even think that this was particularly good research. I was, like, 19 at the time. But the thing is, I do remember that I had literally 2 GPUs to my name, and I did not, like, just optimize the crap out of this thing until I forced it to work, right? Like, basically, this thing worked very, very quickly. So it's not like I tuned this thing into existence. Heh. That would be a great idea. And you know what? Wouldn't it be great if it also had a pufferfish as a mascot? Okay, well, we have some things to try. We at least have some things to try. Very nice. I'm trying to think what else it makes sense to run. I wonder if we can redefine. It's a little tricky when you have this many metrics. I suppose what we could do, it would require a very large sweep, but we could modify our sweep algorithm to take 2 metrics for Pareto optimality, right? It'd be a pretty substantial undertaking. I suppose it's easier to just optimize one way or the other. Sweep over the gamma that you were working on. The gamma didn't do much. Eliminating frame skip, funny enough, did do a lot. Bet that's like the lamest thing imaginable. Sweep on what? This is several things combined into one larger run. I'm trying to see if we can get a reasonable solve at 5 million frames. I think that would be a really cool baseline to have, and that would be like fairly impressive. Have you seen what people are making these days? Yeah, that's their problem though, right? XRL? What? What the hell even is that? Explainable RL? In some sense, we have demystified we've demystified a heck of a lot of what RL is with this stuff, right? Like there's still stuff that doesn't make sense and is surprising, but way, way less than there used to be. I'm trying to think if there's anything else specific to this. Small mini batches. Small mini batches equals higher variance. Oh, you know what? There is actually one thing. It's a relatively small thing, but there is a tweak that I could test. So difficult that you have to test these tweaks, though, with full sweeps. Actually, why... Well, I'll leave it for now. Neptune's like rate limiting us or something. It's really obnoxious. But there is one small thing that we can do, which is we can compute advantage stats over the entire batch. Yeah. Hmm. What's like the big Facebook hyperparameter tuning library? There's SK optimized now, I suppose. Oh, they don't have a ton of methods, do they? Yeah, they don't really have. They kind of just have a thing. I don't understand this whole scikit brand, like, because this looks like too small of a project to even be in scikit. Yeah, this stuff is so freaking bloated. Hyper opt, I suppose. These are not. These are like not good algorithms, my guy. I am a little bit confused about the gamma annealing thing not being good. I'm a little yeah, also, what the hell is this? Like, what is this, right? Oh, actually, okay, it is kind of running slightly longer experiments. That's fine. As long as it's doing something reasonable. Yeah, but at that speed, it could literally be running full Atari, so... At least with Puffer's optimizations, it could be. So that's fine. We'll see how this goes. Oh, wait, I'm stupid. I'm real stupid on this, aren't I? Shoot. Eh. We'll let it go. Just in case it does something, but... Yeah, I made one mistake with that sweep. It's fine. We'll let it run regardless. Cameron, go for a run. Let me demonstrate to you why that is not going to happen. Hang on. Let me go demonstrate to you why that's not going to happen. And then if we're going to go back 2 days, so yeah, that is why there will be no additional running right now. Go to a bar then. I don't think when I honestly don't remember the hell the last time I've gone to a bar. I rarely drink these days. I do sort of want to just sit here and think a little bit about the problem though, right? One thing with RL, what would you do? Well, I assume that you're constraining it to something that I can like clearly formulate as an RL problem. And the thing is, like, there are a lot of things that I would solve if I could formulate them specifically that I have decreasing confidence the farther I get away from my own like base of knowledge. Like, it would be pretty cool if you could get yourself RL into a material science sim to like actually create new materials. That would be like second coolest thing. coolest thing would be is if we could get RL into deep biological sim and actually solve all the dumb biological problems that we have, like, disease and aging and stuff. But presumably that's a bit broad. Yeah. I honestly think the most likely outcome of this is literally just improve hyperpram sweeps, like improve tooling, like reduce overhead so we can run more and bigger sweeps faster, and then sweep for like sample efficiency versus sweep for wall clock, right? This still does not solve like well, it's somewhat unsatisfying that this does not really give us an effective way to leverage more compute. But presumably if we continue to do this, it'll at least tune into like the multiple update steps regime. And also to like slightly larger models. We could also go try to like do the hyperpram opt be distributed, right? That would be really good for studies. If we could do like reasonably quick 1,000 experiment sweeps would make a decent difference, right? Okay, I think that in between this other research, that's going to be the thing then, right? Literally just improve hyper sweeps, do the tiniest bit of architecture work. I suppose I should have known and started with this, right? I suppose I should have known and started with this. But I mean, ultimately, hey, right? I am the most pessimistic person ever about RL literature because I've read it, and I've seen the difference between what works and what works on paper and in practice. And even I underestimated severely how bad it was going to be. So I think I've got my work cut out for me as soon as I'm a bit better rested. I'm not going to start on it now because I've got to go a little early today anyways. Um, but yeah, we do some basic casual sweeps. Is there a good way I can think of to even do distributed sweeps? There probably is, right? Yeah, no, there totally is. have to think about it just a little bit, but how to set parameters which scale with model size. Yes. So that would be mu p. That is actually very useful. I have not had the time to go and figure out about how to get that to work with muon. I've been told by people whose research I trust that this does work very well together, at least for large models. So, if anybody wants to make a small-ish but very useful research contribution, eliminating the dependence of a couple key hypers on model size would help quite a bit. Yeah, so that does actually work. This still doesn't solve the sample reuse thing, right? The sample reuse thing is still kind of annoying. Oh yeah, also, can't we technically... No, never mind. I was gonna say that there should be a clever way that we can cut out an inference pass, but I think we're fine on this. The architecture is pretty well optimized, frankly. We could study data staleness. Yeah, there are a lot of other things that we can study, but I think literally the conclusion of this is just we need to sweep this other regime that we haven't optimized Puffer for at all and do some experiments there. And then ideally we should have our sweeps being able to run faster. Let me just think if there's an obvious way to do... It wouldn't be torch run, would it? It would kind of just be a bunch of sub-processes, right? Like a distributed sweep. Assuming it's like a single GPU distributed sweep, yeah. Like one GPU per run. To make it 6x faster. And we could mess with that. I don't necessarily even think we need to quite yet, but we could mess with that. I do suppose one of the core issues is that with the slower ends, right? Hyperparam opt does get harder. Well, it's not necessarily with the slower M's, it's just with harder problems in general, right? And problems are made harder by M's being slower, right? Fair enough. So I guess we kind of need to really... We need to, like, really understand... I guess, like, stable hyperparameter zones would be a useful thing to study, right? Like, generally just better understanding hyperparam stability. There are a lot of these papers that kind of say, oh yeah, we have one set of hypers out of the box for everything. We have kind of, at least in the high data regime, we kind of actually saw that work for most of our M's. There are a few key hypers that are just kind of annoying to get fixed. Though, wonder if there's an angle where by annealing gamma and lambda, there might be some sort of, like, annealing angle on those. Might be tricky. Might be tricky. And this is, of course, it's going to take a while. I mean, going from 90 million, which is really, it's 90 million at 4 frame skip. So going from that sample F down to this is already like a market improvement. So this is already, well, if we can get something like within 40 mil on real full breakout, I think that would be probably the benchmark. So yeah, a combination of setting up and running sweeps, figuring out a few additional knobs to sweep over, doing analysis, and then making our sweep code run faster is probably the next block of work I've got. Don't think there's any way this can get messed up. I guess technically the only minor detours I could imagine would be a few things on architecture. How much compute are you using for this? Literally 1 GPU per sweep. So you're just running like a few minutes per experiment max. I have 7 sweeps going right now, but I think Neptune is like rate limiting me or something, so they're not playing nice the way that they're supposed to. But yeah, in theory, I should be able to spin up, 10 sweeps or whatever at a time. Does it tell us anything that... I suppose the last thing I'll want to think about for today. Does it tell us anything that we're able to do better with no frame skip? That means that we have to solve a harder credit assignment problem. It's actually kind of funny that that does anything, right? Hmm. Well. What GPU? 4090s and mostly 4090s. Our fastest, we have one box with a nice 5090 in it that I use for stuff I want to finish quicker. Puffer has 20 4090s total. rotated with 0 frame skip. I'm pretty sure that 1 frame skip means use every frame. I think it's like every nth frame is the way it's implemented. At least it should be. That's a good point, though. Yeah, so that is the way it's implemented. So, this is 1 frame skip means use every frame. That's a good thing to check, though. Thank you. It could have been the other way. Okay. Why does this feel unsatisfying? Well, I suppose one of the annoyances with Breakout, right, is it's a really long game. So it's quite possible that with like our really big batches of data, it like barely even gets to play a full game, right? So I suppose what I would do is I would probably pick like some intermediate point, right? When I go to do research, I probably should go pick some intermediate point as the starting point here. 0 meant no frame skip. The 8 frame skip never worked. Yeah. So 8 is usually too much. So for like Pong in particular, I think we do get up to 8 frame skip sometimes, but if you go any higher, like you literally can't react at all. It's already kind of funny that it works with whatever the heck is in there at the moment. Okay, so today is Tuesday. I have a few more meetings planned this week. I think, but outside of that, I think that what I'm going to do is I'm going to just plan on trying to actually get some proper frickin' rest tonight. And then tomorrow, I think we will start on, well, we'll look at the results of this, and I'll launch some more sweeps, but we'll actually do some dev work on trying to make the sweep tool itself faster. We'll add a few small things for that, and we'll see if we can get the turnaround time for this to be something more reasonable, right? Because realistically, right, if we assume 2 minutes per experiment, 30 experiments per hour, we should be done in like less than 8 hours per sweep. So I should literally be able to do... Yeah, I mean, ideally I should be able to like have multiple sets of these sweeps running per day. Or, I mean, that's for a 200 sweep thing, right? If we did distribute it, ideally we could get a 1,000 experiment sweep. Just have really, really high confidence. I also want to figure out how we analyze like stable hyperparameter regions. I gotta figure out how we do that. I could definitely, for any fixed set of hypers, I could definitely do like an analysis of the stability of that set of hypers, right? By perturbing. Magnesium is your friend. You know, you're probably right. You're probably right, actually. I have that and I haven't taken it in a while. Thank you. Um, hmm. I'm gonna actually go get that if I don't have any left. I think I do. It's one of those things, right, where I have like every reason in the world to just be exhausted. So it's like, well, of course I'm exhausted. But yeah, there probably are some things I could do to improve the recovery. We do have the slight problem with the current sweep algorithm that the recommendations kind of get slower over time. I like the idea, though, of doing hyperparameter perturbment. Just real quick. If I know for tomorrow. And then the one other thing is herb. And that we should be able to do pretty quick. Hey, Weston. I'm about to head off for today because I got a meeting in 10 that I got to go get ready for. We will see the results of this tomorrow. For folks who've been watching, thanks for tuning in for the short stream. Puffer.ai, if you're interested in this generally. It's all open source. Look at that. We just got 3.3K today. Start the repo. It's free. It helps me out a ton. If you want to get involved, join the Discord. A lot of the work around here is a lot more accessible than you would expect. Don't need crazy math or science background, so there is work there as well. A lot of it looks like low-level game programming, and that actually contributes to research as well. And other than that, if you're interested in RL generally and you'd like to learn more, you can follow me on X. I post all sorts of RL content, including guides for newcomers that you can't find anywhere else. So thank you, and I will be back tomorrow.